All of us are familiar with Idaho, famous to potatoes. And those of us here at the University of Idaho have heard a lot of talk lately about the university's interest in dairy research. We're also surrounded, of course, if you could see, out the windows, by rolling hills of wheat, lentils, garbanzo beans, and other crops. But how many of you realize how important aquaculture is to the state's agricultural productivity? You may not be aware that the vast majority of the U.S. trout grown commercially for food is grown in Idaho, which accounts for over 75% of the production. Our next presenter is University Distinguished Professor of Animal and Veterinary Sciences, Ronald Hardy, who's based in Hagerman in southern Idaho and directs the university's Aquaculture Research Institute. I should also mention that we have a new ARI facility here on the Moscow campus, and we have a planned grand opening for this facility later this month. Please help me welcoming Ron.
Thank you, Janet. You had me confused there when you were talking about potatoes, but I think I'm on track now. Thank you all for coming. I am going to discuss with you the development of sustainable feeds for aquaculture, how we're improving global food security with fish. I'm going to cover about 5,000 years of development in 6 minutes, so stick with me here. I'll go as fast as I can. Well, it's already come on, Ron. Okay, let's start with this. What is aquaculture? Just to bring you up to speed here, it's a farming of aquatic organisms. This includes fish, shellfish, crustacea, other animals, including turtles, frogs, sea cucumbers, and many others, seaweeds, and so on. It's the fastest growing animal food producing activity on the planet. And there's many types of aquaculture. In Idaho, we use flowing water systems. You can see in the upper level there, that's trout. They're floating pens that are used in marine and freshwater systems. Ponds, you're probably familiar with, growing carp, shrimp, catfish, tilapia. Intertidal beds where shellfish and seaweed are grown. And more recently, the development of land-based recirculation systems. This is not a new activity. The oldest written record of this goes back to a guy named Fan Lee, showed in that picture right there, who wrote a manual on carp farming, explaining that you fertilize the pond and that produces natural food to grow the fish. This is how things stood for the next 2,400 years until the 20th century. That's when things changed, and that's when feeds came into being used. This has been accompanied by a shift between traditional aquaculture, which is family-based farms, low technology, low inputs, to industrial aquaculture, which is different. It's monoculture, technology-driven, high feed inputs, high productivity. And the outcome of that has been to increase the availability of food, seafood for the population over the last few years, up to over 20 kilograms per capita worldwide. And in the red area here, that shows you the contribution of aquaculture. This is traditional fishing. So aquaculture has been responsible for the increase in food availability. What's enabled this to happen are several things. The development of vaccines against diseases was a big development. Advances in reproduction and larval fish rearing, intensive aquaculture system development, but most importantly, to me anyway, the development of feeds. And you can see the arrow there I put in 1970. That's when the first feeds were developed that were really scientifically developed. And this was done because we were finally able to understand and measure the nutritional requirements of fish. Then this enabled us to make complete feeds. And it's because of this, farm production increased about 20 times. We call this the Blue Revolution. This has increased food security for over 3 billion people. What made this happen also was something we were lucky with. We use fish meal as a protein source. Fish eat fish. But by 2007, there simply wasn't enough being made in the world to supply all the needs for fish feed. So people turned to plant proteins, and the challenge with that is, how do we turn carnivorous fish into vegetarians? This turned out to be kind of hard. Fish require 40 essential nutrients, and plant proteins don't have the right mixture and content of these essential nutrients. So when we replace fish meal with plant proteins, we see all kinds of new problems, including what you see in the picture there, skeletal deformities associated with phosphorus deficiency, but there are many other problems, cataracts, enteritis, you name it. So to conceptualize what we need to do to overcome these problems, I turn to the old standby, Maslow's hierarchy of needs. You all studied probably this somewhere in your education. And going up the pyramid, you go from the basic needs for survival up to security and safety, social needs, and so on, eventually reaching the top of the pyramid where you've achieved you've achieved the best. So I changed this to Hardy's hierarchy of feeds. At the bottom, we have the nutrients that are needed just to get by, followed by, as we go up the pyramid, higher levels of knowledge, including feed ingredient knowledge, feed formulation, and to get to sustainable feeds. The basic research we've done provided the foundation, but we have serious knowledge gaps in these areas still. They remain, and those are in the areas of the optimal nutritional needs for health and growth, and feed ingredient knowledge as we switch to plant proteins. To illustrate this, I got a table here that shows the essential amino acid requirements of freshwater fish. Now, these are the main freshwater fish on the top, and I want you to look at all this, but notice that there are numbers in all the little boxes. And when we turn to marine fish, guess what? That's not the case. Surely we're going to change here any second. Here we go. So what you see here, looking at the major marine fish, and remember, aquaculture is pretty much going to expand in the marine sector. We have a lot of unknowns. We don't know the amino acid requirements for these fish, so we can't really formulate clever feeds that support good health when we do this. So what do we do at the University of Idaho? What we've done is we've worked very diligently for years to replace fish meal in feeds. We determine the dietary requirements, as I mentioned. We characterize plant proteins. We conduct feeding trials where we replace fish meal. We measure fish performance. We see it isn't very good. We change the ingredients and the formulations, and then we go at it again. The other thing we've been doing is we've been undertaking selective breeding of fish. We've been doing this for over 19 years. We're in 8 generations. Our selected fish grow twice as fast as they did when we started. The selected strain is now used throughout the Idaho industry. But the most important thing for us is that the strain is a model for research to discover genetic markers and understand nutritional adaptation. We've been able to do this because we have great facilities, we have had long-term funding, and we've also converged disciplines. We use genomics, nutritional physiology, herb biochemistry, physiology, histology, immunology, and finally go to the farm scale to see how our labs tests are validated. Right now, the main focus of our work is to try to understand the mechanisms of nutritional adaptation. We're looking at changes in the GI tract in our selected fish. We're looking at differences in muscle protein synthesis, amino acid turnover, and also changes in the intestinal microbiome that accompany these dietary changes. The global impacts of our research are far-reaching. People around the world are using sustainable feeds for salmon and trout. The new knowledge we're generating will accelerate the development of these feeds for marine fish. We're training the next generation of fish nutritionists. And most importantly, we're making available more fish to feed the growing population. Thank you very much.
Thanks so much, Ron. I always enjoy seeing Idaho trout on restaurant menus as I travel across the U.S., and your talk offers enlightening information about how research at the university responds to the concerns related to food security in the world. Thank you, Ron. And I didn't make you talk about potatoes.